right, we are starting chapter 5 today, and chapter 5 is mostly review of stuff that you have already learned about, just an extension of the trig stuff that we already talked about. So remember those identities that we talked about, the sine squared of x plus the cosine squared of x equals 1. We're going to be doing a lot of that kind of stuff, showing that one side of an identity equals another side. So we're going to, and hopefully when we did this stuff in chapter 4, you guys didn't love it, and I would say probably not fantastic at it either. I'm hoping that this after we do more stuff, you guys will get a little bit better at it. So just to review quickly the reciprocal identities, we have sine, cosine, and tangent, cosecant, secant, and cotangent. Reminding cosecant are reciprocals of each other. So sine could be written as 1 over the cosecant. Cosecant can be written as 1 over the sine. Cosine can be written as 1 over the secant. Secant can be written as 1 over the cosine. I think this is all stuff that you guys know already anyway. Tangent is the same thing as 1 over the cotangent, and cotangent is the same thing as 1 over the tan. Can I flip the page, you guys?
Yeah.
No.
Quotient identities. They were, you had the tangent of x. What did tangent of x mean? Tangent of x was what?
Cosine.
1 over
Sine
cotangent.
Cosine. Cosine over
Sine over, it was sine over cosine. Tangent was sine of x divided by the cosine of x, and the cotangent of x was equal to the cosine of x divided by the sine of x. Pythagorean theorem identities. Please make sure that you get these down. The ones that I've talked about up until now, probably not huge, because you probably have those, memorized already anyway. But this one right here caused you guys some grief. So probably a good idea to get these down. Write them in your notes again. Have easy access to them. So when we're working on these things, you guys can just quickly look up what they mean. All right, so we have the sine squared of x plus the cosine squared of x is equal to 1.
Ooh.
You guys remember this one? But there was also another way we could write this. 2 other ways that we could write this. We can move things around a little bit. I could take this sine squared of x and subtract it from the left-hand side of the equal sign, which would mean I would have to subtract it from the right-hand side of the equal sign as well. So you could also write this Pythagorean theorem identity as the cosine squared of x is equal to 1 minus the sine squared of x. You also, though, could take the cosine squared of x and subtract it from the left and the right, leaving you with the sine squared of x is equal to 1 minus what, you guys?
Cosine squared of x.
Cosine squared of x. Put a box around these or something, because these always come handy. There were 2 other Pythagorean theorem identities. Can I flip?
One more.
The other one of the other ones was 1 plus the tangent squared of x. 1 plus the tangent squared of x is equal to the secant squared of x. So that's the main one. But let's move things around a little bit. If I wanted to solve for the tangent squared of x, what would I get? If I wanted to solve for this tangent squared of x, what would I have to get rid of?
The one.
Yes, I'd have to get rid of this 1, which, by the way, it's a positive 1, and it's being added on to the tangent squared. So I can subtract 1 from the left, then I would have to subtract 1 from the right. So I'd have the tangent squared of x is equal to the secant squared of x minus 1. But you also could solve for 1 by moving the tangent squared of x. How would I move the plus tangent squared of x? Subtract it. So you subtract it from the left, you subtract it from the right. So 1 would be equal to the secant squared of x minus the tangent squared of x. The box around those. The last of the 3 of them is 1 plus the cotangent squared of x is equal to the cosecant squared of x. We're going to do the same thing. Let's solve for the cotangent squared first. Cotangent squared of x would be equal to what?
Cosecant squared x minus 1.
Yep, got to subtract the 1 that's out in front. So we'd end up with the cotangent squared of x is equal to the cosecant squared of x minus 1. And we also could solve for 1. 1 would be equal to the cosecant squared of x minus cotangent squared. Very good. Cosecant squared of x minus the cotangent squared of x. These 3 things. Are your other 3 identities. All right, new stuff. Actually, I don't know that this is necessarily new. I don't know. I can't remember how much detail we got into with this. These are called the
So last week you worked Thursday.
co-function identities.
They switch your. So how many days have you been?
All right, when we were graphing sine and cosine functions, we talked a lot about how when you take a sine function, you just shift it over. Do you remember doing that when we would shift sine and cosine functions left and right?
Yeah.
Oftentimes the sine function would lie right on top of the cosine function. This is what's happening here. If you have the sine of pi over 2 minus x, that is equivalent to having the cosine of x. So the sine function shifted over a little bit is the same thing as having a cosine function. We talked about that. We actually showed that. The cosine function, if you have the cosine of pi over 2 minus x, that is the same thing as having the sine function. And though we didn't get into graphing tangents and cotangents and such, if you have the tangent of pi over 2 minus x, you would get exactly the same thing if you graphed the cotangent of x. As would happen if you have the cotangent of pi over 2 minus x. You would have the, take a wild guess, you guys.
Okay.
The tangent of x, yep. Same thing happens with the secant function and the cosecant function. Can I flip?
Alright, you're good.
You have the secant of pi over 2 minus x. You would get exactly the same graph as the cosecant. cosecant of pi over 2 minus x is the same thing as the secant of x. Couple more even and odd identities. The sign of the opposite of x is the same thing as having the opposite of the sign of x. So what that means is, I'm going to draw just a really quick sketch of the unit circle. I'm not going to explain every single one of these things, because I think once I explain one, you'll kind of get the gist of what I'm saying. But if we are in quadrant 1, and this is quadrant 4, our sign values, remember sign values are our y values. In quadrant 1, are our y values positive or negative? They're positive. Okay, so I'm just going to put a little note here that signs are positive. What about down here in quadrant 4? Are our y values positive or negative?
Negative.
They're negative. So our sign values here are negative. The sign minus. So this says to us, if you have the sign of a negative x, so in other words, we start here at 0 degrees, and we move down. We go down in a negative direction. Are you with me here? All right, let's say we just stop right here. Is our sign value going to be positive or negative?
Negative.
It's going to be negative. Well, that is the same thing as taking the opposite of the sign if we had rotated in a positive direction, the same number of degrees that I had rotated in a negative direction. So in other words, I start here, but I rotate up that same number of degrees instead. Our y value will be exactly the same as the y value that we got in quadrant 4, except it's going to be exactly the opposite, because in quadrant 1 it is a positive and not a negative. The same thing happens with all of these. I just wanted to explain to you what exactly is going on with this. So if you have the sign of a negative x, it's the same thing as having the opposite of the sign of a positive x. The cosine of a negative x is equal to the positive cosine of x. Now if you think about that, when you are in quadrant 1 versus quadrant 4, the cosine values are the x values. The x's are positive in both quadrant 1 and in quadrant 4. So if I rotate in a negative direction, the cosine value is going to be positive, but if I rotate in a positive direction, the cosine value is also going to be positive. That's why we don't have a negative in front of the cosine of x. The tangent. The tangent of the opposite of x. The tangent of the opposite of x is equal to the negative tangent of x. The heat.
Yeah.
Thank you. So the tangent of negative x is equal to the negative tangent of x. All right. Cosecant of a negative x, that is the same thing as the negative cosecant of x. The secant of negative x is equal to the secant of x, and the cotangent of a negative x is equal to a negative cotangent of x. Let's start putting this to use a little bit. Are we good? Can I flip?
1 second.
This is going to be an example. We are going to need to use these identities Good?
Yep.
Example. Okay, so I am telling you guys that the cosecant is -5/2. And the tangent value is less than 0, and your job is to figure out everything else. So the first thing that I want you to do is set up, remember how I always set these things up where I write the sine first, the sine of x, and then write the cosine of x, and then tangent of x. And then right next to the sine of x, I always put its, remember what I would put next to it? The reciprocal. So I put the cosecant of x. The reciprocal of cosine is secant, and the reciprocal of tan is cotan. And the only thing that we have right now is the cosecant. The cosecant of x is equal to -5/2. So if that's what I have, what else do I actually have? You actually have the sine of x too. So the sine of x is what, you guys? It's going to be -2/5. You okay with that? All right, so what I would like you to do now is start thinking about some of the identities that I talked about. Let's see, I think maybe back on this page right here, we talked about this thing right here. 1 plus the cotangent squared of x is equal to the cosecant squared of x. Write this down right now underneath the example that we just talked about. 1 plus the cotangent. Of course, I'm running out of room already.
Where do I write?
Right underneath your example, 1 plus the cotangent squared of x is equal to, what was it equal to, you guys? 1 plus the cotangent squared is equal to the cosecant squared of x. And we, underneath that, solved for something. What did we solve for? One of the things that we solved for was the cotangent, I believe. We said that the cotangent squared of x was equal to the cosecant squared of x minus 1. Yeah?
Yeah.
So the cotangent squared of x is equal to, what was the cosine, or excuse me, the cosecant that they gave us? -5/2. So I'm going to take this cosecant squared, and I'm going to replace it with -5/2. What do I have to do to it? Squared, because it says cosecant squared. So -5/2 squared minus 1. And your job is to figure out what is the cotangent then, knowing that the cotangent is -5/2 squared minus 1. So what is -5/2 squared? What is -5/2 squared? Come on, you guys, what is 5 squared?
25/4.
Thank you. 25/4 minus 1. Do the math here, please. Change it back to a fraction for me. What is 25 divided by 4 minus 1?
4.
5.25.
Change it back to a fraction.
Good. 21/4.
Should be 21/4. So the cotangent squared is equal to 21/4. So if it's 21/4, what do we need to do to figure out what the
Square root.
cotangent is? Yeah, so now we need to take the square root. So we're going to take the square root of the cotangent squared, which is the cotangent of x, which is equal to, well, what is the square root of 21 over 4?
2.291.
No. I don't want any decimals.
I can't get a fraction, I tried.
Yeah, well, that's because it's going to be in radical, the fraction is going to have a radical in it.
Good.
So what is the square root of 4? 2. So on the bottom we're going to have a 2. But the square root of 21 gives you it's an irrational number, gives you a crazy decimal. So it's going to stay as a square root of 21 over 4. Now, you could attempt a tree. But what kind of number is 21? 21 is prime. So if you attempted to do a tree for this, the square root of 21, you would get 3 and 7. That's all you can do, right? There's no pairs of numbers that you can pull out of the 21. So you're going to leave it as a square root of 21 over 2. So now if I go back to this page, I now have my cotangent, which is the square root of 21 over 4. What is the tangent then?
Give me a minute. Hold on. Isn't it 2 over 2, not 4?
Oh, I'm sorry. You know what? You're right. This was a 2. I didn't do the square root part, but yes, sorry. Thank you for the catch. Square root of 21 over 2. If I go, let's see, I'm going to flip back to this page for just a second. It would be, well, it's the reciprocal of this. So it would be 2 over the square root of 21. It would be this reciprocal of the square root of 21 over 4. What I'm going to do is just flip-flop this. I'm going to flip 2, so it's 2 over the square root of 21. But why can I not leave my answer like that? Radical on the bottom. So what do I need to do?
Times it. By square
Very
root of
nice.
21.
Multiply by the square root of 21. By the way, what is the name of the process that I am using here?
Multiplication.
We are multiplying, yes. We are called rationalizing the denominator. In other words, we're getting rid of the square root on the bottom. So we're going to have a rational number on the bottom. What's a rational number?
One without a radical.
One without a radical, sure. Doesn't have to be a whole number. A rational number is a number that can be written as a fraction. Can you write 21 as a fraction?
Yes.
You could write it as 42 over 2. You could write it as 21 over 1. Yeah, you can write it as a fraction, then it's a rational number. All right, what is the square root of 21 times the square root of 21? 21. And then what is what is 2 times the square root of 21? 2 times the square root of 21. All right, so now what we need to do is figure out what we have missing. What do we have missing? We have cosine and cosecant. So if we can figure out what one of them is, then we have the other one as well.
Oh yeah.
But before we get too much further, I want you guys to also remember, and you might want to get out your circles, your unit circles, and I can't remember what color they were, maybe orangish?
Salmon.
Salmon. They were salmon. So get those out, please. And what I want you to do is look to see what quadrant are we talking about right now. Remember that the cosecant value was negative, but the tangent value was also negative. So where on your unit circle does it tell us that the cosecant is negative and so is the tangent? Tangent is not negative in quadrant 3.
2.
Quadrant 2, the cosecant is not negative. It should be quadrant 4. We are talking about quadrant 4. Yeah, third try. I mean, really, there's only 4 choices anyway. So we're talking about quadrant 4 right now. You guys, tangent. What is the tangent? Look at quadrant 4. The tangent is what in quadrant 4?
Negative.
It is negative. Okay? So we need to make sure that we throw a negative sign in front of there. And then if this is negative, what do we know about the cotangent?
It's also going to be,
It's also going to be negative. What about the cosine? Cosine in quadrant 4, positive or negative?
that's a
Positive.
Positive. So what do we know about the secant?
Positive.
It is also positive, okay? But we need to figure out with to remind you, I'm going to flip over here to this page. Actually, I'm going to start another page. We know that the sine of x divided by the cosine of x is equal to what? Is equal to the tangent. Don't we have the sine value and the tangent value already?
Yes.
So we could use this to figure out what the cosine is. Now, let me remind you of this again. What you are trying to figure out is on the bottom of the fraction. So if that's on the bottom of the fraction, what was the little trick that I have told you guys to do over and over and over again? You just switch it with the other side of the equal sign. So you can take this cosine and put it where the tangent is, put the tangent where the cosine is. So the sine of x divided by the tangent of x is equal to the cosine of x. So if you take your sine value now and divide it by your tangent, you'll have your cosine. So help me out because I don't have it in front of me right now. What was your sine value?
Negative 2 over 5.
Okay, so the sine value is negative 2 over 5. What was the tangent would we end up with?
Negative 2.
Negative 2 square roots of 21.
Negative 2 square roots of 21 over 21. Alright. Notice it's a negative divided by a negative, which is going to give us a positive, which is good because we wanted it to be positive because the cosine in quadrant 4 is positive. We have to divide this though. So my suggestion would be to do this. Negative 2 over 5. We are dividing a fraction by a fraction. That's the same thing as multiplying by its reciprocal. So I'm going to multiply by negative 21 over 2 square roots of 21. You guys with me still?
Yes.
Kind of.
What can I cancel out? First of all, I can get rid of the negatives, right? I'm not going to worry about those. I can get rid of the 2's on the top and the bottom. What do you have left?
Nutritious equations.
21 over 5
Square roots of 21.
radical 21. But we can't leave our answer like this.
Of course not.
So what do I multiply by? Square root of 21 over the square root of 21. Thank you. All right, so we have 21 square roots of 21. And then on the bottom, 105. Very good. We're going to have 5 times 21 is 105. Now, I think 21 out of 105, I think that reduces. 21 over 105 reduces to 1 over 5, 1/5. So we're going to end up with the square root of 21 over 5. Square root of 21 over 5.
I didn't have to do that because I just looked at the other one and I just said sum the total and figured out myself. So I got like the same answer without really doing anything.
Okay, so just, what did you tell me that again?
Because like sine is opposite over hypotenuse, and then we got the answer for tangent is opposite over.
So you drew out your triangle
Yeah.
and then that way? Okay, that's fine. I'm going to talk about that in just a minute. I'm going to go back. Gosh, what page am I on here? What do we get, you guys? Square root of 21 over 5, which means the secant is the reciprocal, so we have 5 over the square root of 21 times the square root of 21, square root of 21, so we end up with 5 radical 21 over 21. Okay, very good, and I'm so glad that you brought that up because I want to remind you that I did teach you guys some stuff, I'm out of pages of course. I did teach you guys some stuff last semester, and we talked a minute ago about we are in quadrant, we're in quadrant 4. And so what was the piece of information that we started with? Can you guys refresh my memory? We started with the fact that the cosecant of x was equal to negative 5 over 2. Negative 5 over 2. What does cosecant mean?
The opposite. of sine.
That's just fine.
Cosecant is the reciprocal of sine. Sine is opposite over hypotenuse, so cosecant of x is equal to the hypotenuse over the opposite side. Are you okay with that? Okay, so we just flip the two. So if I draw, remember how we had to draw those triangles like this? Remember this? We had a right angle here. We always drew one side with the x-axis. And what they're telling us in this, if this is x, or theta we'll call it, if the cosecant is negative 5/2, and that's the opposite side over the hypotenuse, what do I put where? The hypotenuse goes where?
On the longest side.
On the longest side right here. Is the negative sign going to go with the 5, or is it going to go with the 2?
Wait, no.
It has to go with the 2, and the reason the hypotenuse always has to be positive, but also because this would be the side that is opposite the theta, and it's a y value because it's headed down. Are you with me? It's a y value, and it's down. And in this quadrant, when you go, well, any quadrant, if you go down, it's negative. So we have a negative 5/2. What just happened?
I wrote
That's
a
what I
5 as
wrote.
a 2 up there. You wrote 2 5s.
Go negative 5.
And I'm still caught up. You said 21 was the prime number, and that just threw me off the lesson.
Oh, I meant to say, hold on, I did say 21 is prime, then I went on to say how its multiples are 3 and 7.
Yeah.
Sorry.
You said it
That's not what I meant. 21 is not prime, but its only factors are 3 and 7, which are prime. 3 and 7 are prime.
Yeah.
I'm sorry. Can I throw you off the whole lesson, really?
Yes.
No.
Okay, so here you guys, we have the Pythagorean theorem going on. You could just go, 5 squared minus negative 2 squared.
Teenager ended, it's alright.